Hello everyone, my name is A. Anithana from Sri Venkateshwara College of Engineering from CSE AI branch. Today we are going to discuss about basic connectivities and truth table logic equivalence in mathematics. So we are going to the basic introduction of logic connectivities. Logic connectivities are fundamental symbols used in professional logics. They help in constructing complex logic statements from simple proposition. Understanding these connectivities is essential for analyzing the logical arguments. There are different types of basic connectivities. Firstly, we are going to the primary basic connectivities that are and, or, not, implies, and biconditional. Each connectivity has a unique true value based on the true value of its component. This connectivity is from found building logical expression. First, we are going through the AND connectivities, which is also known as conjunction. The AND connectivities is denoted by the symbol, the power symbol, as you can see in the screen. The conjunction is true only if both propositions are true. If in take an example of truth table, if both are true, then only the result will be true. In the truth table, the AND connectivities will be only for the combination of TT. Now we are going for the next value, that is OR connectivities, that is disconjunction. The OR connectivity is represented by the symbol V, and for V or we are used like inverse of V. The disjoint is true if at least one of the proposition is true. In previous case we saw that if both are true then the connectivity will be true. In this case we are going to see if the condition in truth table is just one is true, the conditions will be true. In a truth table, the OR connectivity yields false only for the combination of false false. Select the non-connectivities negation. Non-connectivities depict by the symbol which we can see in the screen. It reverses the truth value of proposition if it is true. It's become false and vice versa. If the condition is true, it will be become false, and if it is false and it will be becoming true. Thus the line it says the truth table for not shows has P is true, negation P is false, and vice versa. If negation P is false, then it will be true. If it is false, it will be true. The implies connectivity, conditional connectivity. The implies connectivity is the symbol by the arrow mark you can see in this screen. It is expressed as a logical implication where P implies Q. We can write like that, like P implies Q is only false when P is true and Q is false. Certain, like if you take a truth table, if in left side if the condition is true and the other side Q is false, then only the conditions will be false. In truth table the implication is true cases except for true comma false. Now we are going to see about biconditional connectivities, which is also known as equivalence. The biconditional connectivity is denoted by both the side arrows, as we saw in this previous conditions. It indicates that both propositions are either true or false together. In the truth table, the biconditional is true for the pairs true true and for the false false. For constructing truth table, we will be going ahead like a truth table list of all possible true values of logical expression. Each row in table corresponds to unique combination of truth values for variables. Truth tables help visualize how different connectivities interact with one another. Logical equivalence. Logical equivalence occurs when two statements have identical truth values in all scenarios. Two express are equivalent to the two expressions are equivalent if they yield the same result in truth table. Common examples of equivalence expressions includes P implies Q and negation P or Q. Applications of basic logic. Understanding basic connectivities and truth table is crucial in computer science and mathematics. They form the basics for logical reasoning, programming, conditions, and circuit design. Mastering this concept enhanced problem solving skills and analytics thinking. Feel free to customize the part of presentation.